Okay, make sure you know this. Under Canadian law, interest on a mortgage can be compounded at most semi-annually. However, mortgage payments are often made monthly. It doesn't say it in your book, but they also do bi-weekly and accelerated bi-weekly. These monthly payments form an annuity whose present value is the principal originally owned. So they're talking about this formula over here, our present value formula. Now there's a problem with this formula when calculating a mortgage. Since the payment period and the compounding period are different, in all of our questions we had compounding periods that were the exact same as our payment periods, we cannot calculate the monthly payment on a mortgage by using the formula for the present value of an ordinary simple annuity. We use the Tvm Solver instead to represent monthly payments and some semi-annually compounding. On your Tvm Solver, these are the two buttons we're talking about. We're talking about PY, which is payments per year, okay, and CY, which is compounding periods, per year. Make sure you guys know this information. You will be tested on it. Now we're going to start taking up a mortgage. We're going to go through the steps to get to the Tvm Solver. So, take out your calculators, the graphing ones. We'll quickly go through the steps. First off, you have to turn it on. I'm not going to tell you that. You just need to know that. Okay? Second step. You need to find a button that says Apps. It's just purple on some of them. Okay. You hit Apps. The very first one, so your third step. Number 1 says Finance. Yeah, you either hit Enter or you hit number 1. Okay? These are steps. Once you're in Finance, your fourth step, number 1 again, says Tvm Solver. You need to go to that. Either push 1 or you push Enter. From there, and this is what all of our stuff is going to be modeled off of, you're going to have the options for N, okay, I as a percentage, PV, which stands for present value, which if we're dealing with a mortgage, our mortgages deal with present value because we're borrowing the money right now. The next thing says PMT, which is our payments per compounding period, or I guess it stands for payments per term. Make sure we know that. These are our monthly payments. You also have FV, which stands for future value. Oh, that's not it. And then we get down to what we just defined above, which are our PY and your CY. And then at the very bottom it says PMT, and it gives you two options, end and begin. Okay? Those deal with when you're paying your mortgage, when you're making these payments per term. It either says begin or end. And what that means is you're either making the payments at the beginning of the month or you're making the payments at the end of the month. Okay? So N is number of compounding periods. Okay? I is interest rate. PV is what? Do I need to show you that? Yes, sir. This is payments per period, we'll call it, as in compounding period. Future value. And then we have PY and CY already defined above. You need to know all of these for your test. You're allowed to use these calculators for your test, but you'll need to know how to use them. Okay, so our very first example we're going to talk about here. The example says, the confirms, I guess that's the name, take out a mortgage at $210,000 at 5% per year, compounded semi-annually for 25 years. So, we need to make sure we understand this. First of all, is a mortgage a present value or a future value? Anyone know? I'm going to tell you, it starts with this. It is a present value, a mortgage. So in other words, the amount of money they borrowed, they took it out right now. Okay? Present means right now, so they have $210,000 they got on loan from the bank right now. Future value deals with our annuities. Okay? That's the other formula. Okay? We could have put FV if we liked. That would have stood for our future value of an annuity. So how much it'll be worth after, say, 10 years. The present value is when we have a certain amount of money, how do we pay it off after a certain amount of years? So we have a present value of $210,000. It says that they are being charged an interest rate. Okay, so that is our I percent here in the calculator. 5% per year. And we got to look at their compounding periods. It's compounding semi-annually, which is the max a mortgage can compound. So what does that mean? Compounded yearly, semi-annually. What is this number for CY? 2. It's happening twice a year. And we'll do a couple comparisons, but we're going to say like a average mortgage that their payments are every month, which means how many times do they pay a year? 12. Okay? That's all the essential information we're going to need for this to calculate, okay? So, we're going to put this into the calculator here. So, what this means is a very important piece of information which we didn't quite put down here, is that we need to figure out how long they would like to take to pay off this mortgage. So, in other words, their years. It says they would like to pay this off in 25 years. Okay? Very important piece of information. So, we're going to put down a interface of what our calculator looks like, and we're going to decide what numbers to put in order to solve. So, like we said before, we cannot use our formulas to solve these because the compounding periods are different. They're paying 12 times a year, but it's only being compounded at max twice a year. That's what mortgages legally can be compounded at. So, we need to figure out what numbers to put in for each of these. We define them on the other page. Our N stood for our what? Number of compounding periods. Now, what that is, if you look on the side, we have that formula over here. That is going to be our compounding periods times the number of years. Lucky for you, in this calculator, it'll do the multiplication for you. So, what that means is because this is a 25-year mortgage, okay, and it's being compounded how many times a year? Twice. We'll be multiplying those two numbers. You can literally put into the calculator 25 times 2 and just go down, and it'll solve it for you. I know G-Hill is smart enough to know that that is 50. Okay? All right. Our interest rate. Now, on our formulas before, when we were doing our future value, or an annuity, and our present value, we had to calculate I by taking the interest rate and dividing by the compounding period. This calculator will do that for you. Okay? So you don't need to use this formula that we did have to use before. You just put in the interest rate. Our interest rate is 5%. So we're going to be putting in the number 5. Now, because we said this was a mortgage, we already said that that is a present value. That means they've taken out a loan for $210,000. They have that amount right now. So that's the present value of the mortgage. That's how much money they have borrowed. So for present value, we put in $210,000. Our payments per term or per period, for now we're going to leave at 0. Okay? Don't got to put anything in. Future value, we aren't gaining money. We haven't invested any money. We're paying off a loan. So we're not trying to find the future value of anything. So that's going to be 0 in this case. Now we talked about what PY was before. Anyone remember? Payments per year. These people are paying off a mortgage, and we said that the mortgage was being paid off monthly. So how many times per year does that mean they pay? 12. Good. So that's 12 payments per year. What does CY stand for? Yes, how many times this mortgage or the interest rate compounds a year? What is it? Twice. Good. Now, most mortgages, this is important on your calculator, most of the mortgages you'll do a payment at the end of the term. Okay, so at the end of the period. We're going to make sure ours is at the end. Make sure end is highlighted on there. If they were to ever say beginning, we would switch that. But for now, we're going to go with an easy example. So we have all of these numbers plugged into our calculator. Now, what I need to show you guys how to do is how to calculate the payments per term. This is what we're going for right now. So that means your cursor needs to be on payments or PMT. Okay, so in other words, it needs to be highlighted there. We have to have the cursor sitting here on the 0, just flashing. Okay. On your calculator, when it is flashing there, you're going to hit these 2 buttons. You're going to hit alpha, which on many of your calculators is green. Okay, so you hit that button first. And then on many of your calculators, this button is blue. You hit this second. It's the enter button. You need to hit alpha enter each time when it's highlighted there in order to solve for it. Okay? So you're going to hit alpha enter. What did you guys get? Okay. Anyone notice something special about this number? It was negative. We got minus 4, 6, 5, 6.50. Okay? So, what this said is that their monthly payments needed to be $4,656 in order to... Sorry, that is way too high. I thought it was odd. I'll show you where we made our one little mistake. On our N is compounding periods, or sorry, how many times we make payments. So we're not making payments 50 times. That's how many times it's being compounded. We're making payments 12 times a year. Okay, that makes way more sense. So, when we plug that in, we get the number 300. So we're making 300 payments over the course of 25 years. That makes a lot more sense. So your number now after alpha enter is negative 1,221.37. Now it's negative because what that means is you have to subtract from the original $210,000. You have to subtract $1,221.37 every period in order to have this completely paid off after. Okay, so say that before, just as a good learning opportunity, we had a number that was 4,000 something, right? Maybe I'm not used to calculating mortgages over a certain amount of time, so let's say it was 4,000, I think it was 656, something like that. Okay, that seems like quite a bit of money per month. We can go and kind of verify this because we actually need to figure out the interest rate anyways. So we're going to take these 2 numbers over to the next page, and we're going to calculate how much we would have paid over the life of this loan or the life of this mortgage. Okay, so our 2 numbers. We went and checked, and we're making the assumption this is the right number, but we're going to use this as a learning opportunity. Let's say we weren't able to tell. We're going to go through the same process with that, and we have to try to logically make sense of this. Does this make sense as a mortgage payment? So, how many times did we make payments over the course of this loan? We just figured it out again. How many times do I pay a year? 12. How many years was this loan? 25. If I multiply those two, I get 300. So I make 300 payments over the course of this loan. So in order to figure out how much I've actually paid, I need to multiply my monthly payments. Monthly payments multiplied by the amount of payments I make to figure out exactly how much I'm paying into this. So this is total amount paid. Our total amount paid, we take the $1,221.37 that we pay every payment period, and we multiply that by the number 300, okay? We're also, on the side, just for comparison's sake, going to use that original number where we made a mistake and figure out what it would have been. Okay? So we have $1,221.37 multiplied by our number 300. We're going to figure that out. That's going to equal okay, we get $366,411 are our payments. Okay, so our two payments. First one here at $1,221.37. Over the course of 300 payments, we ended up paying off $366,000 or 411. So let's actually figure out how much interest I had to pay. Does anyone remember what the principal was or the original loan? That's right. We borrowed $210,000, which then means if we subtract these two numbers, because the $366,411 was the total amount that we paid. When we subtract those two numbers, 366,411 subtract. We end up paying an extra $156,000, $411,000 on this loan. That's a lot of interest we've paid on the loan. Had it been the other number we had originally calculated, according to this, we paid over $1 million. It's quite the mortgage. And if that had been the right number, we had $1,396,000. Is that 800? Probably about 800. Subtract our $210,000. According to our other number, we would have paid $1 million, $1,186,500 in interest. Right there, that should have kind of tipped you off. That makes no sense as a 5% interest rate. Okay? Now, I want to show you the difference between an interest rate that is just compounded once and how that changes when it's compounded per year. So, if we had really just compounded the interest rate once, that would have been our $210,000. And times 5%, what is 5% as a decimal? 0.05. So this would have been the interest if it was only compounded once. That means they only charge us interest once over the life of this loan. We would take our $210,000 and multiply it by that number. 210,000 times 0.05 is equal to $10,500. $10,500, okay? What that would be is that would be an interest rate, say, if it was only compounded once a year, okay? It'd it'd be $10,500 in interest. But because this constantly compounds, and what that means is after it's charged the interest, they add this amount to the loan. Okay? So if they're adding this amount to the loan, think of it like this. Our new loan in the next month, or the next year, is $2,050,500. I now have that much to charge 5%. So it constantly increases the amount. The downside to it is that we're constantly also paying this off, so this amount is dropping by $1,221 every month. So every month I'm taking off over $1,000, but every 6 months I'm being charged 5%, well, roughly 5% interest. It's more like 5 divided by the compounding period. But the idea is this number here, once you calculate it, it should not have made sense to you that you would be charged over $1 million in interest on a mortgage payment. It wouldn't be worth it, right? So if you had happened to go farther with our original number, doing this here, finding out how much interest they were charged, should have told you that I definitely have the wrong number. I need to go back and recalculate. Okay? We figured out that they paid $156,411 in interest on the loan. That's a lot of interest. That's over half of the original principal they paid in interest. So, page 450, numbers 1 to 6 is your homework.